All right, we're finally on the last video of 3.2. So this is video 6, believe it or not. Um, and what we're going to do is just tie everything together. So you've learned 4 methods of solving a quadratic equation, which is the same as finding the zeros of a quadratic function. And now we're just going to look at 3 different questions, I believe. It's yeah, 3 different questions. And we're going to talk about how we decide what method to use, and then we're also going to introduce that idea of finding approximate solutions. So just to practice that for when we get to the application questions. So question number 1, what should we do? Well, our 4 choices are factoring, solving algebraically, square root or completing the square, or quadratic formula. When I look at this one, if I try to factor this, are there 2 numbers that multiply to give me -2 and add to give me -1? Yep, -2 and 1. So that's what I'm going to use. I'm going to factor this to x minus 2 times x plus 1. And because this said, sorry, I forgot first part of this. This is find the zeros of the quadratic function. So finding zeros, you're going to let y equal to 0. So this equation is equal to 0. This expression is equal to 0. I've factored it, and now I can set each factor equal to 0 and solve. I would end up with what makes x minus 2 equal to 0 when x equals 2. What makes x plus 1 equal to 0 when x equals -1. So this equation has 2 solutions, -1 and 2. Now, could I have used square root method? Nope, because of that x, right? I can't solve algebraically. I can't take a square root to find an answer. Could I have completed the square? Well, you can always complete the square, but because the b coefficient is odd, I wouldn't. Could you use the quadratic formula? For sure. And when you use the quadratic formula, you're going to find out that the discriminant, so the value underneath the square root sign, would be a perfect square. And then you'd end up simplifying to -1 and 2. Awesome. So notice it says give exact answers and approximate solutions rounded to 3 decimal places when possible. This question, it wasn't possible, right? They would be silly to put 0.000. So this is one of those scenarios, not possible. Let's move on to question number 2. Question number 2, again, we're finding the zeros of this quadratic function. So we're going to set it equal to 0 first, and then we're going to pick our method. So you have 4 options. First off, solve by factoring. Are there 2 numbers that multiply to give me -3 and add to give me 6? Definitely not. Can I solve algebraically? Nope, because of that x term, right? I can't isolate the squared. So now I want to solving by completing the square. Well, the middle coefficient is even, so I sure could do that. Or I could use the quadratic formula. So I'm going to leave that up to you. I'm going to solve by completing the square because I think it's good to practice it more and more to kind of make it less and less scary. But if you want to use the quadratic formula or you want to do both, that's great. So to solve this one by completing the square, it's got a coefficient of 1. So I've got x squared plus 6x. And then I'm going to leave some space and put the -3 on the end, or just bring the 3 to the other side. Then you're going to find the magic number. So you're going to take half that middle term and you are going to square it. Half of 6 is 3, squared is 9. What I add, I also have to subtract so that I don't change the expression. This is my perfect square trinomial. It's going to factor to x plus 3 all squared, right? Square root of 9, half the middle term, the 2 numbers that multiply to give you 9 and add to give you 6, whatever works in your head. And then we've got -12. Then I'm going to add 12 to both sides, and I'm solving algebraically. So I get plus or minus the square root of 12 is equal to x plus 3. Then I'm going to simplify the square root of 12. Now you'll notice I often do a lot of work off to the side. I don't like doing things like simplifying within my question because it's too much to write over and over again, but I do want to show my work. So I will take something like, hey, if I'm simplifying the square root of 12, okay, it's 2 root 3. So then I'm going to get -3 plus or minus 2 root 3 is equal to x. Now that is my exact solution. So my exact solution is going to be this x equals -3 plus or minus 2 root 3. My approximate solutions for this one, I'm going to plug it into a calculator. Now, you can plug into your calculator x equals -3 plus root 12, or you could plug in -3 plus 2 times root 3. I find that more work. So if I was going to find approximate answers, I actually wouldn't simplify. I would just plug this in. So then we're going to grab our calculator And we're going to plug in -3. Let's see if I can get this calculator to show a little nicer. Okay. Ooh, it's tiny. Okay, I'm going to plug in -3 plus root 12, so -3 plus the square root of 12. And it's set to 3 decimal places, so I get 0.464. And then I'm going to plug in -3 minus the square root of 12. And that gives me -6.464 to 3 decimal places. Awesome. So that one is done. What about this last one? So for this last one, let's check. Can I solve this one by factoring? No, there aren't two numbers that multiply to give me 1 and add to give me 1. Could I solve using the square root method or algebraically? Nope, because there's an x term. Could I solve by completing the square? Yeah, I could. I don't want to. So I'm going to solve this one using the quadratic formula. So again, I'm going to make this equal to 0. I've got x squared minus x plus 1, which means I have an a value of 1, a b value of -1, and a c value of 1. My quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a, which is going to give me -1 plus or minus the square root of -1 squared minus 4 times 1 times 1 all over 2 times 1. All right, this is going to simplify to 1 plus or minus the square root of 1 minus 4 is -3 all over 2. This is an imaginary answer, or it's a complex solution, whatever works in your head. And then we are going to simplify this to 1 plus or minus the square root of 3i all over 2. And like I was saying in the last video, this is a great answer, but this textbook is like, let's write it in the complex form. So it's going to be 1/2 plus or minus the square root of 3i all over 2, just to be fancy. Awesome. Hopefully you guys are feeling good about solving quadratic equations or finding the zeros of quadratic functions.